They put a fly in the Matrix. In 2026, FlyGym made headlines. FlyGym is a reinforcement learning environment for simulating the adult fruit fly. Critics of this publication quickly pointed out that FlyGym is only the physical embodiment of a virtual fly. It is only able to simulate fly movement, touch, sight, and smell. What most of the critics missed is that FlyGym already ships with an example that uses FlyVis. This is a neuroanatomically accurate simulation of the fly's visual processing. Advancements from FlyVis have shown that you only need to know 2 details about the neuroanatomy of the brain to simulate it. You only need to know synapse connections and the polarity of each neuron. FlyVis also demonstrated that machine learning can be used to predict resting voltages and action potentials using only the synapse and polarity data. FlyVis also showed advancements in simulation by discovering new groupings of neurons and minimizing the types of neurons in the fly's visual processing. In addition to this, companies like Eon have reproduced the full fly brain in simulation, and are finding that the predicted neural activity matches the real biological fly with 91% accuracy. In 2024, Eon Systems showed that the leaky integrate and fire model of the neuron was a strong enough predictor for their 91% accuracy result. Eon's mission statement is to turn human brain simulation into a tech sprint rather than a century-long research project. I believe in them. With better brain simulation algorithms, advancements in GPU processing, and models for the open source community to collaborate on, we are closing in on the possibility of a digital immortality. To address the main complaints of the brain's complexity versus a computer, I disagree. I believe that it is a matter of an optimization problem for different media. If you try to start with a CPU, it seems impossible. If you approach this problem with a GPU, it seems possible but overly complex. If you start to use neural-specific hardware, you are already much closer. See China's Darwin monkey chip that can simulate 100 billion synapses. Not quite a human's quadrillion synapses, but it is getting closer. Advancements in quantum computing or even diamond-integrated circuits may already extend Moore's law into this range. If that doesn't work, there is also potential for a paradigm shift in computing, a new GPU per se. Extropic is developing thermodynamic computation. This could improve the entire leaky integrate and fire model to the point of having it run on 1 thermal compute unit per neuron.